Let's take a look at the warm-up. Warm-up 63, number 1. Construct and label an obtuse scalene triangle. So what does that mean when we're drawing an obtuse scalene triangle? What do you think we need to do?
A triangle with the side that's more than an angle that's more than 90 degrees.
Yes, more than 90 degrees. That's where I would start. So I would start with an angle that's more than 90 degrees. So I can tell that's obtuse. And then what? What do you think, Elijah? That one. What did you just say? They're all sides must be different lengths. And so sometimes that's hard to do, like we're not using a ruler. But how can I show mathematically that all sides are different? Does anybody know the marks that I'm going to make? So what do you think? Would it be what? The lines, right? They all need to have a different number. So if I put one line here, I would put 2 lines here and 3 lines here. That shows that all 3 lengths are different, and that's what shows that they are scalene. So those are the marks. Some people like to put different numbers, like an 8, a 7, and a 12. That does show that they're all different, but the mathematic marks that you want are these right here that show they're all different. Okay? All right, 2. A cylinder is sliced vertically. Draw the 2D shape to represent the slice. So what does vertically mean? What do you think, James? Up and down, right? What else do we call that vertically? What else do we call vertically? Parallel or perpendicular to the base? Perpendicular to the base, right? Perpendicular means you make a T. So vertical is perpendicular to the base. And so what's the 2D shape that results when we cut it vertically, James? A rectangle. So just draw a rectangle on the paper. Don't write the word, because it says draw the 2D shape. All right, last one, name the shape below. So you need to name it in 2 different ways. Name it for the side lengths and name it for the angles. Anybody besides James have an answer this morning? Aiden? Equilateral, yes, because they're all equal sides. I can see that because they all have just one line through it. Equilateral. Another name. Let's hear from a girl this morning. The boys seem to really be on their math game. Name it for the angles. Ladies, we're going to wait on one of you. What is it? Acute. Thank you, Ava. Acute. Because all of the angles are acute. So it's an acute equilateral triangle. All right, questions? No? Okay, let's put that to the side for tomorrow. One more warm-up for this week and one more day for this week. Remember, you don't have school on Friday. Tomorrow is the end of the grading period. End of this 9 weeks. We only have 9 weeks to go. Then you're 8th graders. Whoop, 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 whoop. And then after that year, you're high schoolers. Oh, my goodness. All right, here we go. We're going to talk about box and whisker plots today. Let's get your notes out. Box and whisker plots. If you don't have these notes, go pick them up. Let's look at the bottom part. These are the notes that we're just going to look at. We're going to talk about what the different parts of a box and whisker plot are. So you should have seen these. If you went to school here last year, you should have seen some box and whisker plots. If you were in my 6th grade class, we did a lot with box and whisker plots, a lot, so that we understood them, we knew how to make them, we knew how to read them. But let's look at the different parts. So what's the big thing that you can tell from a box and whisker plot? So here's some data that's graphed on this box and whisker plot. They've already done it for us. You'll always have a number line below it because a box and whisker plot itself has no numbers in it. You cannot see from a box and whisker plot the individual data pieces. There's only 5 things that you can tell from a box and whisker plot. So you can tell the lower extreme. That's the lowest number in the list. The lower extreme. We also could call that the minimum. Minimum means lowest, right? So you might see that called the minimum. Write that on there, minimum. Right there with lower extreme. You can see it called the minimum or the lower extreme. That's the lowest number in the data set. All right. Next, let's just go down here to this end. This is called the upper extreme. It's the highest number in the list. What else would we call it? If this is the minimum, what would the upper extreme also be called, James? The maximum. Thank you. So those are the smallest and biggest numbers in the data set. Everything in between are numbers higher than the minimum, lower than the maximum. All right. What's another important thing to point out? The next thing, if you were making this, would be you would find the median or the middle number. The median tells you the middle number. Okay. Sometimes it could be one number, or sometimes it is the mean of two numbers, right? When we've been finding the median, when we were doing that on our own, sometimes the median's one number. Sometimes if it's two numbers, you add them together and divide by 2. That's how you find your median. And then you have the lower quartile and the upper quartile. That's the name for the end of this first quartile, and that's the name of the end of the third quartile. Okay, so how you would find that would be you would find the lower, the upper, then you would find the middle. To find the lower quartile, then you're going to find the middle of this bottom 50%. So each of these quartiles is how much percent do you think, if these are called quartiles? What's the percent? Quartile sounds like what word? Quarter. And a quarter is how many percent? 25%. So each of these quartiles is 25%. So when we find halfway between the median, which is 50%, and here, when we find halfway, that's going to be 25%. And the median's 50%. So what would the upper quartile be if it's halfway between 50% and 100% or the whole thing? What is that one going to be, James? 75%. So the thing to know about these is each quartile is worth 25%. Each one is worth 25%. So it could ask you about the middle 50%. If a question asked you about the middle 50%, we would be talking about these numbers here. If they asked you about the lower 25% here, the lower 50% would be you would add these two together. If we talked about 100%, we would be talking about the whole entire box and whisker plot. Do you see how that works? Okay. All right. So the other thing that you need to know is the interquartile range. The interquartile range is the difference between the upper and lower quartiles. So a lot of times you're going to be asked what the interquartile range is. That's the difference between the lower quartile and the upper. You would subtract. You would subtract the upper and the lower. So that's the range of the box. That's the middle 50% or the range of the box. And remember, for range, you're going to subtract. That says you must subtract. All right, does this all sound familiar to you? Yes. Those of you with your Chromebooks open, you probably should close those. Thank you. All right. Questions about any of these notes? We're going to try to make a couple of them. before we move on today. Okay, let's look up here at the top. So we've got two different examples that we're going to work through. Let's work through the one on the left first. All right, so our data set, our numbers are 12, 8, 10, 16, 5, 15, 18, and 14. So we're going to create a box and whisker graph and identify the 5 data points. What's the first thing that we need to do before we can start graphing minimums and maximums and medians? What's the first thing you always do with a data set? Put it in order from least to greatest. So our smallest number is 5. And then 8, 10, 12, 14, 15, and 18. Oh, and that's why you should not do math in pen. 16 and then 18. Thank you. Did I get them all that time? Okay. All right. 5, 8, 10, 12, 14, 15, 16, and 18. So the first thing that you need to do is you need to graph the minimum. What's the minimum? 5. So we're going to put a dot between the 4 and the 6. Put a dot for your minimum. Next, what are we going to graph? The maximum, 18. So just go right above the 18 and make a dot. The next thing you need to do is find the middle of the box. So let's find the median. 1, 2, 3, 4, 5, 6, 7, 8. So there's 2 in the middle. So halfway between 12 and 14. And what is that number? 13. Draw a line right here at 13. If I didn't know it was 13, what would I do? Add them together and divide by 2. So if I added them together, I'd get 26. 26 divided by 2 would be 13. Okay, next, we need the lower extreme. So we've got to find the median of the lower set of the data. So if there's 2 numbers here, you're going to split it here. I'm going to split that right there. That's where 13 would be. So the 12 goes with this lower set. The 14 goes with the upper set. So I need the median of the lower set. So I need a number that's between 8 and 10. What would that be? 9. So put my line here. And then I need a number between 15 and 16. 15.5. So that's kind of hard to graph here. So it needs to be right here between 15 and 16, maybe a little closer to 16. And then you draw your box. There's your box, and there's your whiskers. Box and whiskers. So really, it's just a matter of finding your high, your low, your median of the data, and then the median of the lower and median of the upper. Okay? So we have a data set that we made our graph by, but can I see all of these individual numbers on this graph? No, right? So that's not what a box and whisker plot is for. It's not for looking at your data as individual pieces. It's for looking at your data for groupings of 25%. Does that make sense? Okay, so let's answer some questions. What's our lower extreme? What was our lower extreme? If you don't remember, look down here. 5. Lower quartile. What's our lower quartile? So remember, we found our lower quartile here. So we said, what number is our lower quartile? 9. Our median, what was our median? It was between 12 and 14, so it was 13. Our upper quartile, 15.5. And our upper extreme is 18. Those are the 5 data points that you can find from a box and whisker plot. Seem familiar? Anybody that did not do these last year? Let's answer some questions now. What's the range of the data? Remember, the range is the high minus the low. We're not talking about the interquartile range. What is it, Elijah? So you've got to find an actual one number for a range. 13. So we would say it's 18 minus 5, and so our range is 13. Interquartile range, right? That's the range of the box. So that's the upper quartile minus the lower quartile. So 15.5 minus 9. 6.5. Find the mean of the data to the nearest tenth. How do we find the mean? By how many there are. Okay, if you don't have your calculator, you may get it. And we're going to find the mean of this data. So we're going to add these numbers up. And what are we going to divide by? 1, 2, 3, 4, 5, 6, 7, 8. Add them up and divide by 8. $12 and 25/100. Everybody get that? Okay. And is that pretty close to the median? Yeah, our median is 13 and our mean is 12.5. Those are both measures of center. And they're pretty close in this case. Is there an outlier? If so, identify it and explain how it affects the mean. So was there an outlier? Do you remember what an outlier is?
One that is not even close to any of the others.
Yeah, one that lies far away from the others. It's an outlier. Is there a number here that's far away from any of the others? No. So no, there is not an outlier. If there was an outlier, do you know what that would do to the data? It wouldn't really affect the median because the middle number, so if this, instead of being an 18, if it was an 81, do you see how that would be an outlier? It'd be far away from everything else. So it wouldn't affect our middle, but it would affect this last whisker section, and it would make it really long. So you would use, for a measure of center, if there's an outlier, you would use the median. You would just use the actual middle of the data. You would not use the mean, right? So have you noticed how when a teacher is doing your grades, you can get like a 90, an 85, an 83, a 100, and then a 0, and your average like tanks? You're like, how did I go from an 88 to a 60? How did you go from an 88 to a 60? Well, that 0 is an outlier. It affected your mean or your average grade, and it affected it a lot. Would it affect the middle of your scores? No, it would just be the lowest score, but it didn't really affect the middle. So if there is an outlier, when you're wanting to look at your measure of center, you're going to use your median. You're going to use your middle. If there's not an outlier, the better score to use is going to be your mean. It's a better average. Does that make sense? All right, so let's look at our next box and whisker. What's the first thing we want to do? I want to hear from girls. This one is going to be the girl graph because all we've heard from is the boys. So girls, put on your thinking caps and let's go. What's the first thing we're going to do? Put them in order from least to greatest. So our lowest number is 20. And next is going to be, and how many 38s are there? 2. And 46. And 54. 55. 62. 65 and 70. Did I get them all? Yeah. All right. First thing you do, step 1, put them in order from least to greatest. Then on your box and whisker, what's the first thing we're going to identify on the box and whisker? The lower extreme or the minimum, so put a dot above the 20. The upper extreme, 70. And then what? We got to find some medians. We've got to find the median of the data set, and then the lower median and the upper median. So how many data points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. So how many are in the middle? 1. 4 in the bottom. 1, 2, 3, 4. 54. 1, 2, 3, 4. So there's just 1. So put a line at 54. So that's close to 55, but not exactly on it. And then we need to find the median of the upper and lower. Now, is that 54 going to go with either of those two sides? No. You leave this out when there's just 1. Leave that out. So we want to find the middle of this data set down here. So what's halfway between 38 and 38? 38. Nope. When it's the same number, it's just 38. So that's over here close to 40. And then let's look up here. What's halfway between 62 and 65? Anybody know? So if you can't just identify it, what should we do? Elijah, do you know? Maybe, but can we prove that mathematically, ladies? What do we do? Shay? Yes, let's get the answer mathematically. 62 plus 65 divided by 2. And Elijah was right, 63.5. So we're going to go over here. And do we have all of our points now to draw our box and whiskers? Yes. And whisker, and whisker. Now we can answer some questions. What was our lower extreme? 20. Lower quartile was 38. Median was 54. Upper quartile, 60. Remember the math we did? 63.5. And our upper extreme is 70. Pretty easy this year. I think the second time you look at it, the second year, it becomes like, oh, why was that so difficult in 6th grade? It becomes a little bit easier. All right, what's the range of the data? The high minus the low. 70 minus 20 is 50. Interquartile range, remember that's the range of the box. So it's 63.5 minus 38. $25 5/10. Find the mean. So that means we're going to add it up and divide by. And how many are there? 9. $49 and 7 repeating. Is that what you all got? I feel like maybe I might have done something wrong. Is that what you got too? Okay. All right. So how would I write that? 49.7. And how do I show that 7 repeating? Very good. Oh, did it? Did I not round? Okay, so if we're going to round that, that is round. Okay, so that's not really rounded to the nearest tenth. So if it's 49,777, if I'm rounding to the tenth, that 7 tells that 7 to do what? Go up to a 8. So 49.8 would be rounding to the nearest tenth. Over here, if we rounded to the nearest tenth, what would that be? What would that 5 tell that 2 to do? Go up to a 3, 12.3. Last one. Is there an outlier? If so, identify it and explain how it affects the mean. The answer key calls 20 an outlier. I'm not sure that I agree that 20 is that far away from 38, although it says this other data is kind of clumped together. An outlier would normally be a little bit further apart. That's not an extremely long whisker, but they call it an outlier, and so we'll just talk about what that means. So if that's an outlier, how does that affect the rest of the data? So let's look up here. So the average, or the mean, was 49.8, and the median is 54. Those are a little bit further apart than over here, right? Over here, our mean was 12.3, and our median was 13. Do you see how they're kind of close together? So if we were looking at a measure of center, over here we would use the mean because it's a little bit more accurate. Over here, when they're calling this 20 an outlier, do you see that our median is 54 and our mean is less than 50? So an outlier really affects the average or the mean, and so here you would use the median as your measure of center. So use, over here we said the mean as measure of center. And over here, yes, it's 20. So you use the median as your measure of center. So these are two important statements that you should have written on your paper. So if there's an outlier, no, so you use your mean as your measure of center. Over here, there is an outlier. It's 20, so you use the median as your measure of center. You need to have both of those things written on your notes. And then we'll get them put in our journal, and then we'll talk about today. So some of you need to be writing. And are we on page 129? Yes. So 129, box and whisker. Box and whisker on page 129. I think if you cut that a little smaller, it should fit on the page. If not, you can put it on 128 and 129. People are still writing. I had surveys, the last page of the surveys on 127. I had this right here, biased or unbiased on 127. Do y'all have that in your journal? Okay. We'll use whatever next available page you have. Mine's 129. Well, make sure your table of contents matches your page. And I'm going to put my notes above my examples just because that's the way I like it. I'll have to look. $126 is a blank page. All right, so you'll notice the next thing on our agenda is IXL CC.6. So you're not working on all those past due IXLs. In class today, you need to do CC.6. You're using your notes from Monday about biased and unbiased. And you're going to write that on a Post-it note. We're out of those little charts. And then you also have to do BB.15. And that's on box and whisker plots. So instead of doing a paper skills practice from Monday and today, you're going to do these two IXL sections, CC.6 and BB.15. And then if you get those two done and turned in, you can turn them in on the same Post-it note. Don't average them together. If you get those done and turned in, then you can work on IXL. Some past due stuff. And if you don't have anything to work on, come see me and I'll help you out. Questions about the rest of today? Okay.